All right, we've got a couple of equations to solve here. There'll be another couple more coming. This type here with brackets, okay? This one with brackets, but x on this side as well, so a little bit harder than this one. Now there's two ways of doing this. I'll show you the first method, which is probably what you would do. Here we're going to remove the brackets, so multiply that out. We have 5 times 7 is 35. And here this is 5 times minus 2 is minus 10x equals 15. Okay, now what I'll do here, I'll subtract that 35 from both sides of the equation. That gives me minus 10x equals, that gives me minus 20. Careful here, divide both sides by negative 10, which knocks out that. And you're going to get here x is equal to simply 2. Right? Okay, the other way of doing it, and you can only do this if that 5 divides into 15. I could write that as I could divide the 5 into 15. I get 7 minus 2x equals 15 divided by 5 is 3. Then I subtract the 7 from both sides. I get minus 2x equals minus 4. And then I divide both sides by the negative 2. And I get the same result, x equals 2. So it's a little bit faster, but obviously if that was a 7, you'd have to expand the brackets out. On this side, no shortcut here, we have to remove the brackets. So in doing that, I get 2x plus 2 equals 4 minus x. Now what I like to do, I like to get the x's all over to one side and get it over and done with. So I'm going to add x to this side, it makes it go out. Add x to this side, that gives me 3x plus 2. And that gives me equal to 4. Subtracting the 2 from both sides, we get 3x here is going to equal to 2. Then we divide both sides by the 3. I'll just put a 3 underneath here, like that, because a common error is people write as 3 on 2 for some reason. So that's the correct answer, 2/3. Right? Yeah, that's done. Right, these next two questions here, we've got the fractional equations. Here you notice that the fraction bar or the reticulum is underneath the whole lot. Here it's split up. So there's a couple of different techniques to look at. Now when it's like this, I can simply just multiply both sides by 3, which makes it very easy, doesn't it? That becomes 4 minus 2x equals 21. Now I'll subtract the 4 from both sides. I get minus 2x is equal to, that's going to give me minus 17. And divide by minus 2. And that gives me x equals, that'll be a positive, so that's going to be 8.5 or 8.5. Or some people just leave it as 17/2. I think that's okay, but I prefer to leave it in the decimal or fractional form. Right here, I'll show you two methods for this one. Now we can't multiply that by 2 and that by, no, we just can't do that. So we need to find the lowest common denominator of 2 and 3. It's the lowest number that both 2 and 3 will divide into, which is obviously 6. Now what we do then, we put them over the common denominator of 6, just like a normal fraction. Okay, and we'll multiply this one by 3 over 3, because 3 over 3 is 1, and this by 2 over 2, and that's 1. So we're not actually changing the value of this because we're simply multiplying by 1. But what happens, of course, this top part multiplies, we made it multiply, so we get 9x all over 6, minus this becomes 2x all over 6 equals 5. That's 9x minus 2x, which is 7x all over 6 equals 5. And then this comes across, we get 7x equals 6 times 5 is 30. And that gives me x equals 30 over 7, or if you like, 7 and 30 goes 4 and 2/7 is your answer. Now the other way of doing it, I need a little more space. Let's pop it over here. 3x over 2 minus x on 3 equals 5. It's sort of find the lowest common denominator, but instead of putting it over it, you multiply each term by the 6. Now that's what you've got to be careful of. That's the only trap with this. You must multiply each term by the 6. Don't leave any of these terms out. So now this becomes, so 2 into, that simply becomes 2 into 6 goes 3, so that's 9x. And 3 into 6 goes 2, minus 2x is equal to 30. So 7x equals 30, and we get the same result, 30 over 7, okay, or 4 2/7 as your final result. I actually prefer this technique only because it's reinforcing simplification of algebraic fractions, which is another part of the course. So you're doing the two things at once. But if you want to speed up the result, there's nothing wrong with that technique either. Okay, well, it's done now.